All right, so today we are going to be working with similar figures and similar solids. This actually covers two sections in our book, 10.4 and 11.7. So let's do a little recap on when we were working with similar figures way back when, okay? So if two figures are similar, two shapes are similar, that means they're the same shape but different size. And all of their side lengths are going to be proportional. All right, remember some of those words coming out of my mouth? All right, so scale factor was the ratio of corresponding side lengths. What does ratio mean? Another word for ratio. Fraction. A ratio is just a fraction. Okay? So scale factor is the ratio of corresponding side lengths. And they're saying that if that's A over B, if you get A over B, then the ratio of their perimeters is also A over B. That's something that we learned way back when, was that the ratio of perimeters is equal to the scale factor. Okay? So that's something else I'm going to go ahead and say here. Cross out the word and. But this is also just the scale factor. Okay? Well, now what we're going to talk about, what's new today, is that we're going to have the ratio of area and the ratio of volume. And so the ratio of two shapes' area is actually going to be equal to the scale factor squared. Okay, it's going to be equal to the scale factor squared. That's what a squared over b squared means. It's just take a over b and square it. We've actually seen that in our homework the last week or two, is where we take a fraction and have to square it, okay, or cube it. All right? And so that gives us our ratio of the area of those two shapes. Well, to find the ratio of the volume of those two shapes, all we're going to do there is take that scale factor, and this time we're going to cube it. Raise it to the third power. Okay, because remember, a over b cubed is the same thing as a cubed over b cubed. Okay? Questions? No questions. All right. Something else as far as keeping this straight, as far as keeping it straight, what you're supposed to be doing. Remember that perimeter is just a distance, right? Perimeter is the distance around a shape. And distance is measured in just units. So feet or inches or meters. And so I would think of this as being in, say, feet. Well, then area is measured in square units. And so it's square feet, which is why we take the scale factor and square it. Okay? And then volume is measured in cubic feet or cubic units. And so that's why we take that scale factor and we cube it. All right? All of these things are related. So make sure that you understand how they're related to each other. All right? The concept of perimeter, area, volume. Good to go? I realize we haven't used them yet, but any initial questions on what we've talked about so far? Okay, let's go ahead and work an example. So taking a look at our first example, they say, what is the ratio of the smaller to the larger of perimeter? Now, they already walk us through this. I'm not quite sure why they walk us through this already, but if we look at these two trapezoids, we see that this side and this side over here, those are corresponding sides in those two trapezoids, right? And so the ratio of the lengths of corresponding sides, they even say that right here. The ratio of the lengths of corresponding sides. What is that? What does that mean? Ratio of the lengths of corresponding sides? That is the scale factor. The scale factor is the ratio of the lengths of corresponding sides. That's the definition of scale factor. Okay? And so what we're going to do is we're going to take our two ratios. They say small to large, so I'm going to say 6 meters over 9 meters, and I need to reduce that down. Now, one thing I hope you notice is that meters are going to cancel. Just like when you're doing unit analysis or dimensional analysis, you can cancel units just like numbers. Okay? And then 6 over 9, 3 goes into that 2 times and 3 times. And so we get 2/3. Now the reason I showed that with the units involved was because I wanted to demonstrate that when you're talking about a ratio, I don't care if it's the ratio for perimeter, area, or volume. Anytime you're dealing with a ratio, units are never involved. Okay? The units go away. They're gone. All right? They cancel out. Okay, so there's our ratio of perimeter, because the ratio of perimeter is just the scale factor. Okay? Ratio of perimeter is just the scale factor. So now they want to know, what is the ratio for the area? The ratio of area. Well, how are we going to find that? Not cubed, because area is in square units. So we're going to square it. Take the scale factor and square it. 2/3 squared, which means 2 squared over 3 squared. So our ratio of area is going to be 4/9. Questions? Now, you're always going to want to reduce down fractions, okay? You're always going to want to reduce fractions. That's going to come into play if they give you all, it's going to come into play all the time. Anytime you have a fraction, make sure it's reduced. Okay, let's just keep that short and simple. Okay, let's look at problem number 2. Problem number 2 says the area of the smaller regular pentagon is about 27.5 square centimeters. What is the best approximation for the area of the larger regular pentagon? Well, they're talking about area, and they give us side lengths of these 2 pentagons, but a couple of things are wrong here. One thing's wrong is that we've never talked about how to find the area of a pentagon before. So does that mean we can't work this problem? No, because we can find the scale factor of these 2. We have corresponding side lengths. Therefore, our scale factor equals what? Right, 4 centimeters over 10 centimeters can be reduced down to 2/5. Okay? So that's my scale factor, my ratio of corresponding side lengths. Now what I need to do, since they're talking about area, I need to find my ratio of area. So I'm going to do what? The ratio of area is going to be 2/5 squared. So 2 squared over 5 squared is 4/25. Okay? All right, now here is the reason why we're learning this. This is what this is used for. We know the area of the smaller pentagon is 27.5 square centimeters. They want us to find the area of the larger regular pentagon, right? So we're going to set up a proportion. We know the ratio for area is 4/25. So we're setting up a proportion. The area they gave us is for the small pentagon. Notice the fraction, the ratio is 4/25, so it's small over big. And so that's how we have to write our fraction. Small over big. They give us the small area, we need to find the big area. So we're still writing it small over big. So now I have a proportion. How do we solve proportions? Cross multiply. If I have a fraction equal to a fraction, I cross multiply. So I have 4a equals, well, what is 25 times 27.5? 687.5. Okay, and I need to divide by 4. And so our area is going to equal 875. They did not tell me what to round to, and it's a terminating decimal in my calculator, so I'm just going to go ahead and use all 3 decimal places. And this is square centimeters. Questions? Okay, so what I would like you guys to do is follow this example, but work the problem right next to it. Ready, set, go. Okay, so taking a look here, they tell me the scale factor already. They give me the scale factor. And so if my scale factor is 3/4, how do I find the ratio for my area? Because remember, I'm solving for an area here. I square it. Take the scale factor and I square it, which gives me 3 squared over 4 squared. So that's now my ratio of area. Okay? And so now that I know that, I can set up a proportion. 9/16 equals. Well, now they give me an area. But is that the area of the big parallelogram or the small parallelogram? That's the big parallelogram. The area of the large parallelogram is 96 square inches. So is that going to go on the top of my fraction or the bottom of my fraction? Bottom, because that's where the big number is. Okay, and so I'm looking for the area of the small parallelogram. Cross multiply, I get 16a equals 9 times 96. 864. Okay, well, I got to divide that by 16. And so what do I get for my area? 54, and I need units here, right? Square inches. Okay, questions? Okay, what if they give us a problem like this? They give us the area of 2 similar triangles. They tell us the triangles are similar. They give us the areas. They want us to find the ratio of perimeter. What's another word for ratio of perimeter? Scale factor. We're just looking for the scale factor. Okay? So, how do you suppose we might start this problem? 50 over 90. Find the ratio of area. That's exactly it. So find the ratio of area. 50 over 98. Okay, well, that fraction looks to me like it can be reduced. What goes into both of those? 2. All right, so our ratio of area is 25 over 49. But now here's the thing. Remember, the way we find that ratio of area is by taking the scale factor and squaring it, right? That's what we talked about. And so we're looking for what number squared gives me 25 and what number squared gives me 49. And so this is, yes, 5 and 7. So that means our scale factor, otherwise known as the ratio of perimeters, is going to equal 5/7. Questions? All right, let's go to the back side. All right, on the back side here, we're talking about similar solids. And similar solids are just like similar figures in that they are going to be the same shape but different size. And in order for them to be similar, that means any pair of corresponding sides need to give us the same scale factor. Okay? So it shouldn't matter if I'm comparing the height of a cylinder or if I'm comparing the radius of two cylinders. I should always get the exact same scale factor if these two things are in fact similar. Okay? So taking a look here at number 1, or part A I should say, they're asking for whether or not these two are similar. Okay? Well, in order for them to be similar, all corresponding lengths need to be congruent, or the same. Proportional is what I'm trying to say. Okay? So, set up a proportion, just like we did way back when we were dealing with triangles. Similar triangles. We just said, hey, put the dimensions of one of them on top. All right, did that. Well, now looking at the other one, here's something that's going to be important for you to understand, is that these are solids, just like they were when we had two-dimensional shapes that could turn one. Doesn't mean they're not still similar, right? Same thing with solids. I could take a block and I could just set it on a different face. It's still the same block, right? Just on a different face. So this one doesn't show up this way, but I know there's at least one in your homework where your block is turned. So you got to remember, if they are going to be similar, that means the short side has to correspond to the other short side. And the long side on the one figure has to correspond to the long side of the other figure, right? It's the only way it works out. And so looking at this, even though these are set up the same way, what is the side that has to correspond to 2? 4. Has to. There is no other option, because 4 is the shortest side on that other figure. So 2 and 4 have to correspond. Okay? Even though, yes, it even looks that way in this particular figure. Right? Okay. So then these must be 6s. Are these two figures similar? Yes, because they all reduce down to what? 1/2. All right, so that means our scale factor, otherwise known as the ratio of perimeter, is 1/2. What is then the ratio for area? Careful, it's going to be 1/4, right? Because it's 1 squared over 2 squared. So 1/4. What is the ratio of volume? We haven't done ratio of volume yet, but how do I find it?
1/8.
Because you're taking 1/2 and cubing it. Volume is a cubic unit. So to find the ratio, you take the scale factor and cube it. So 1 cubed is 1, 2 cubed is 8. What does this mean? What does this mean? Well, it means the scale factor, or ratio of perimeter, means that since this length is whatever it's going to be, and we know it's going to be 3, but let's imagine we didn't. Whatever this length is, I know that then its corresponding length is 2 times longer. That's what that means. It also means that, well, if I find the perimeter of this front square, whatever that ends up being, the perimeter of this front square is going to be 2 times as long. That's what that means. Okay? If we look at the area, it means that the area of this front square is going to be half the size of the area of, a 1/4 the size of the area of this front square. This area, even shade it in, this area is 4 times bigger than this area. Okay, that's what that ratio of areas means. But not just area of faces, that also goes for surface area. Okay, if we know the surface area of the small figure, that means the surface area of the big figure is 4 times that. Okay? Questions, comments? All right, the last piece then is the volume. The volume. We now know the volume is 1/8. The ratio of volume is 1/8. That means, remember that day I had the water in here and I was pouring water in to show the volume formulas? Okay? Well, I could do the same thing here, except I could take 8 of these and fit it into one of these. That's what a ratio of 1/8 means. It means this guy is 8 times bigger than this guy. Dealing with volume. Right? All right, good deal. So let's keep going here. you are going to see a problem that looks like this on your homework. A couple of them. Okay? They give you the volumes of these two things. They want us to find the scale factor. Okay? They want us to find the scale factor. So we worked a problem just like this on the front side. How do you suppose we should start? 729 over 1,331. All right, so my first question for you is, does anything go into both of those? Is this a reduced fraction? Give it a shot. See if anything goes into both of those. Three does not go into 1,331.
Oh, it's 331? Oh, okay.
Yep. What's your conclusion? No. Nope. It's a reduced fraction, but we got to check. You got to check. You first got to check, try to reduce the fraction. Okay? So since it's already reduced, now we need to look for what number to the third power gives me 729. And what number to the third power gives me 1,331? How do you suppose I'm going to check that? It's by trying numbers. What's 5 to the third power? 125. Oh, that's too small. So try a different one, such as 7 to the third power. What's that give you? Still too small. It's what?
9.
It's 9. Yay, 9. Okay. Now we got to do the same thing for 1,331.
11.
It's 11. Wonderful. Okay. So, what is the scale factor? If we need it, or if they ask for it, how then do we find the ratio of area? Cube? Square both of them. 9 squared is 81. 11 squared is 121. Okay. I think you guys now know enough to be dangerous on this. Let's get to some homework.